Let's look at some discussion questions about this material. Here's one. The gold histogram shows the distribution of so many values, each of which is something. Answer this question, pause the video if you need time to think, and then we'll start the video again with the answer. The gold histogram shows the distribution of 10,000 values, each of which is an average of 900 randomly sampled flight delays. The blue histogram shows the distribution of 10,000 values, each of which is an average of 400 randomly sampled flight delays. Both of these histograms are roughly bell-shaped. The larger the sample size, the narrower the bell. The distribution of all possible sample averages of a given size is called the distribution of the sample average. We approximate it by an empirical distribution. By the central limit theorem, it's roughly normal. The center is the population average, and the standard deviation of this empirical distribution is the population standard deviation divided by the square root of the sample size. A city has 500,000 households. The annual incomes of these households have an average of $65,000 and a standard deviation of $45,000. Answer the following question to describe the distribution of the incomes. The distribution of the incomes may be close to normal or not. We can't tell from the information given. We know that the distribution of the sample averages is roughly normal, but not the distribution of the incomes themselves. In fact, income tends to have a skewed distribution, highly skewed to the right. Here's another question. A city has 500,000 households. Again, the annual incomes of these households have an average of $65,000 and a standard deviation of $45,000. A random sample of 900 households is taken. Now we should fill in the blanks. There's about a 68% chance that the average annual income of the sampled households is in the following range. Well, let's think. So 68% represents one standard deviation, represents the area that's one standard deviation away from the center in a normal distribution. So what we'd like to do here is use the average of the incomes in order to predict the center of our confidence interval here. It's 65,000 is the answer in the first blank. And then to figure out the standard deviation of the sampled households, or at least the standard deviation of the average for the sampled households, what we should do is take the standard deviation for the population, 45,000, and divide by the square root of the sample size. The square root of 900 is 30, and 45,000 divided by 30 is 1,500. So there's about a 68% chance that the average annual income of the sampled households is in the range 65,000 plus or minus $1,500. Here's another discussion question. A population has average 70 and standard deviation 10. One of the histograms below is the empirical distribution of the averages of 10,000 random samples of size 100 drawn from the population. Which one? All three histograms have a center at 70. That's not distinguishing them. It's really something about the spread. You can see that the first histogram has a standard deviation that's about 10. That's in line with the population standard deviation, but we wouldn't expect the standard deviation for the random samples to be the same size as the population distribution. We expect the sample averages to have standard deviation equal to the standard deviation for the population divided by the square root of the sample size. And here, the sample size is 100, the square root of 100 is 10, so the standard deviation of the sample averages should be 10 over 10, or 1. So now the question is, among distributions B and C, which one has standard deviation 1 and which one has a different standard deviation? And the way to tell the standard deviation, remember, for a bell-shaped histogram is to figure out where the points of inflection are for the curve that approximates this bell shape. And in B, I think the point of inflection sits at about 69 and 71. And in C, it looks more like it's at 68 and 72. In B, the standard deviation is 70 minus 69. It's 1 unit. And in C, the standard deviation looks like it's 2 units. So B is the correct answer.